Hello, class. This is Mrs. Juliana again. I am going to finish page 1 with the 30, 60, 90 triangles, and then also move on to page 2 with this video because the last time I've made the video, it was too long to load, so I had to cut it and then load it. So anyway, we'll start here with 30, 60, 90 triangles. This is another special right triangle. And what happens with these, and I can actually draw it bigger now because I got a fresh page. What happens now is you have a 30, 60, 90 triangle right here, and you have a 30-degree angle and a 60-degree angle. With both angles, across from the 30-degree angle right here, we call this the short leg. And you know the two legs come together to form the right angle? All right, one's short, one's large. Now, that's because, if you can imagine in between my hand here, let me zoom out so you can see it a little bit better. If you have an angle, if you make your angle bigger and you think about the side opposite the angle, which is the side in between my two fingertips, as I move my angle to be bigger, then what happens to the side opposite the angle? Well, it gets to be longer, right? So longer, and then if I make my angle smaller, I go inside a little bit, then my angle smaller, my side opposite is smaller. So again, the angles are related in that way to their opposite sides. So the 30-degree angle is going to have a shorter side opposite it than the 60-degree angle. The 60-degree angle is going to have a longer side, and the 30-degree angle is going to have a shorter side. So when you see this 30-degree angle here, what happens is the side opposite it is the short side. And then you have a hypotenuse over here, this little hypotenuse right there, right? Now, what happens with that hypotenuse, oddly enough, if you can imagine this hypotenuse right here, however long the short side is, say it's that long, then the hypotenuse is exactly twice the measure of the short leg every single time on a 30, 60, 90 triangle. And no matter how big or how small it is, that happens just because whatever this is and whatever this is, it's going to be twice. We'll say 1 and 2 just to make our numbers simple. If we have the square root of 2 squared, which is the hypotenuse, minus 1 squared, okay, that's going to be the square root of 4 minus 1, or the square root of 3 for the other side, radical 3, then as I check this out and look at Pythagorean theorem versus the 30, 60, 90 triangle, then the hypotenuse squared is 4 is equal to radical 3 squared, right, plus 1 squared. That's how my sides would line up. Hypotenuse squared is equal to the square of the sum of the sides. So radical 3 squared is 3, and 1 squared is 1, and that does indeed equal 4. So this relationship always occurs with our 30, 60, 90 triangle. All right, so you always find that short side by finding your 30-degree angle, going directly across from it, and mark that short side. All 3 sides have to be long to that short side in the following manner. Whatever the short side is, the hypotenuse is twice as long. So if the short side is 1, the hypotenuse will be 1 times 2, or 2. And then to go to the longer leg, then we have to multiply by radical 3, the short side. Okay, not the hypotenuse, the short side, whatever it is, we multiply by radical 3. So you can check it out for any number of sides. Say this is our 30-degree angle. Here's our short leg here. Okay, if our short leg happens to be 5, then we would expect the hypotenuse to be 10, and we would expect the long leg then to be 5 radical 3, the short leg times radical 3. Let's check it out real quick. Is 10 squared equal to 5 radical 3 squared plus 5 squared? Well, 10 squared is 100. 5 radical 3 squared, and you would have to put that in the calculator if it would just be easier to do it that way. So in parentheses, 5 radical 3, and then squared is 75. All right? So 75 plus 5 squared is 25, and sure enough, that works. Now, the trick with it is, well, what happens if I'm given something other than the short side? So I don't know exactly what the other two sides are, and maybe I'm given this long leg is 7 radical 3, okay? If that's 7 radical 3 and I go back, I have to go back to the short side first. I cannot go back to the hypotenuse because you just have to go around in a circle that way. So in order to go from long leg to short leg, you would take 7 radical 3 and you would have to do the opposite because whatever the short side was, it was multiplied by radical 3 to get this long side. So then to go back, I have to divide by radical 3 to go back to the short leg. So 7 radical 3 divided by radical 3 is fairly easy. The radical 3's divide out. You're left with just 7. And then in order to go to the hypotenuse, you would again times by 2. So that would be 14. All right? So, and if you're going back from the hypotenuse back to the short leg, of course, you would divide by 2. If you're going back from long leg to short leg, you would divide by radical 3. And if you're going short to long, you would multiply by 2. And if you're going short to hypotenuse, you would multiply by 2. Short to longer leg, you would multiply by radical 3. And that's what you do every time. Multiply to go up, divide to go back, just like we did with the 45s. Okay, so we've got these 3 triangles. Now, the first thing I would do is I'd locate my 30-degree angle, and then I would find right directly across from it that short leg. That's the one everything's based on. If you don't have it, then you have to find it through division. So here we have the hypotenuse, which is another good thing to find. If I know the hypotenuse is 8, if I go back to the short leg, then I have to divide by 2. So 8 divided by 2 is 4, and I know x is 4. Okay, that's not too difficult, but then I have to also find the long leg, which is a little more difficult, but not too bad in this case. This side is 4. To go to the long leg, we multiply by radical 3, so that would be 4 radical 3. Not too bad. The next one, you have a 60-degree angle and a 90-degree angle. That tells you for sure, because they add up to 180, that this angle here is the 30-degree angle. Directly across from it is going to be our short side that everything's based on. So we're going to go to it first, and it looks like what we have is our long leg. It's 27. So in order to come to the short leg, then we're going to have to divide by radical 3, which is not as fun, but still doable. So we write it out here, 27 divided by radical 3, at least that's where I'm going to put it. We're going to multiply by radical 3 because we can't leave radical 3 in the denominator. Once again, remember that we have to rationalize our denominators. So when we multiply that, and we did that just because radical 3 times radical 3 is 3. Right? On the top, we have 27 radical 3. They have to stay outside and inside, wherever they are. But then the 3 divides into 27 and makes 9 radical 3. So y is 9 radical 3. And it's good to write that in because then you can see the short side is 9 radical 3. If I want to go to the hypotenuse now, then what we do is from short to hypotenuse is multiply by 2. So we're going to multiply 9 radical 3 by 2. That makes 18 radical 3. And let me just write that out. 9 radical 3 times 2. 9 times 2 must be done because they're both outsides. We only multiply outsides to outsides. So that's 18 radical 3. All right. All right. Last example before we move on to the next page. And I first locate our 30-degree angle. I say, oh, it's 30, 60, 90. Which is kind of bad because it's not as easy as the 45, but still we can do it. So across from the 30 is 5 radical 6, which is what we have, which is nice. That means we're just multiplying, not dividing, which is really great. So x is first. It is the hypotenuse. So the hypotenuse is 2 times the short leg, 5 radical 6. And we multiply, of course, 2 times 5 is 10. 10 radical 6. And that's because the 2 and the 5 are both outside. So we multiply the 2 and the 5 together. And then the radical 6 remains inside the radical. All right, next up, we're going to go this way, and that means we have to multiply by radical 3. So that means 5 radical 6 times radical 3. Now, remember when we're multiplying, we multiply insides to insides. So 6 and 3 are multiplied together, and it makes 5 radical 18. Now, we have to be careful here because 18 is 9 times 2, and it's not simplified. We must divide out or take out not really divide, but take out from the square root any perfect square factor, which 9 is. It comes out as 3, and then it multiplies to the 5. So we have 3 times 5 radical 2 is left over, which makes 15 radical 2. All right, so that's 15 radical 2. And that concludes the first page. Gosh, I wish it does give me some time. I do have a little bit of time left, and it will still load. I'm going to try to explain the trigonometric functions, and then we'll stop with this. Now, the trig functions, if you have a right triangle, I think you've seen these before in your Math 2 class, the trig function is a function whose rule is defined by a trigonometric ratio. So when you have an angle, such as the ones we just talked about, any angle, say this is 47 degrees right here. If I know the angle, then the ratio of two sides in a right triangle is always the same. That means I'm taking a side and I'm dividing by another side. I get the same exact ratio every single time as long as my angle is the same. They used to make little charts and little tables, and they'd set up all these tables with it. And the tables would have sines and cosines ratios no matter what the triangle size is. If it goes big or smaller, it just doesn't matter. You're still going to have, because you're dividing two numbers, you're going to end up with the same exact ratio. And that's what the function is. Now that trig ratio, remember it's like A over B, for an example. Ratio is a fraction. It compares the lengths of the two sides of the triangle, and because you're dividing, they always divide out common factors and end up being the exact same number. All decimals, well, not all, most of them decimals. But anyway, we use this Greek letter, theta, right here, and that's used to represent the measure of an acute angle in a right triangle. So we have an angle, and we have three sides, and those are two of them make a ratio, a trig ratio. So an angle and then a ratio of sides. When I see sine theta, that means the sine of this angle is going to be our opposite over hypotenuse. Now, first thing I would do on here is figure out my opposites and my hypotenuse. And we have the legs are going to be either O or A. They're either opposite or adjacent, and the hypotenuse is always hypotenuse. So you can guarantee that this is going to be the hypotenuse here every single time. You don't have to worry about that. But then we have to locate the angle. Theta, that represents an angle. Opposite, if I go directly opposite, then I come up with the opposite side. Okay, I like to write an O on it right at the very beginning so I know that is my opposite side. All right, now if I take this angle and I go right to the attached side right there, attached is adjacent, and they call that adjacent. So that's all you have. You have a hypotenuse, you have an opposite angle or side from the angle, and you have an adjacent side to the angle. Every single time, opposite, adjacent, hypotenuse. So the sine is always your opposite over hypotenuse. All right, so you go from the angle, find the opposite, it's A, hypotenuse is C, A over C. The cosine is always the adjacent over the hypotenuse, right? So adjacent is B, hypotenuse is C, B over C. And then the tangent is always opposite over adjacent, those two sides. So you just have to relate the two sides to each of the three trigonometric functions. Opposite from theta is A, and adjacent is B. So A over B. All right? So those are the three trigonometric functions with their ratios. And here you have the angle here, and then you have the two sides that the ratio is equal to the sine of the angle. And then you have the angle, the cosine is equal to B over C, and the angle tangent of the angle is equal to the ratio A over B, which is pretty crazy. Luckily, the cosecants are exactly the reciprocal, and they call them the reciprocal functions for that. So cosecant theta is just C over A, or you could say hypotenuse over opposite. Just flip them, reciprocate it. So secant's going to be the reciprocal, so hypotenuse over adjacent, which is C over B, and then cotangent is the adjacent over the opposite, which is B over A. And those are all the reciprocal functions and the trigonometric functions. Now, these are very helpful because if we know there are 3 items that are related, if we know one of them, we can always find the other 2. Or if we know 2 of them, we can always find the other one. And that's what we want to do in most cases, which our examples are going to be like. I'm going to go ahead and stop the video right now and then do a third video for the last part because it only lets me upload a little bit at a time, I have found out, as I've been making video after video after video. And then on the third video, we'll finish this up. And those are the trig functions. All right, stay tuned.